So we've looked at some where we were working with above the mean, below the mean, between two values, right? And so we learned how to use the calculator to be able to find those. And we practiced some of those again yesterday, and I gave you some homework that were mixed practice ones yesterday. So hopefully you've at least looked at some of them or are comfortable with those keystrokes. Make sure you're writing them down. Now, I did get confirmation that you do not have to write them on the test. But today we're going to look at inverse, which just means pretty much we're going to take the process and reverse it, right? So we're going to be still given an x value. You're still going to be giving a standard deviation sometimes. You'll be given a mean sometimes, but you're going to start off with the probability, and we're going to work backwards and find other information. And again, sometimes you'll be looking for the mean, sometimes you'll be looking for the standard deviation, and there is even a case where you have to find both, which we will discuss later. We're not going to put that in today, but we will look at it just in case because it has shown up on the exam in the past. Okay? So, inverse probability means we have the probability. We need to find the mean or standard deviation. Okay? So we're going to work backwards. Now, for the greatest part of this, we can still use the calculator to find the information that we need. Okay? But then we have to go back to that formula for the z-score to get the rest. And we're going to do a little bit of algebraic manipulations on that formula to be able to get the rest. Okay? So it's a pretty straightforward process. Now, as usual, I always made my university students do this by hand, so I don't know those keystrokes, so y'all are going to we're going to work through and find the keystrokes for it. So if you want to look on page 43 in your book, it walks you through the keystrokes. Most of them are going to be exactly the same. The difference is going to come from when we get to the very last, one of the very last things, instead of choosing NCD, we're going to choose inverse normal. All right, so let's look at just the keystrokes. Again, menu, right? Stat, distribution, normal. None of that has changed. Yeah? But then you're going to be in the wrong setting. Okay. Also make sure that it's on variable. Remember, they're going to reset your calculators when you go in to take the test. And when that happens, it'll change it back to list from variable. So even though variable is staying right now, don't get used to that. Because when the calculator's reset, we'll reset it for this test, right? And it'll be reset when you take the actual external. So when that happens, it's going to change it back to list. And you need to change it back to variable. Okay? And you're going to choose inverse normal. Okay? Yes?
When they reset our calculators, it goes into radius. Is that what it
Rate.
does that matter if it's in degrees or radians?
Degrees or radians? We'll see when we get to the trig section. It might there. Okay?
So should we just reset it to the same, back to degrees?
Yeah, because we're not going to work in. We're going to be working in degrees, not radians, for the trig that we do in this course, I think. Yeah. Okay. So the calculator keystrokes are the same, and then what's going to happen is it's going to bring up a menu just like we had before, but now it's going to give us some information. We're going to be putting in different information. So if you look at, yes.
Sorry, I'm not learning what to do with my calculator, and I don't know where.
Okay, well, let's see. So what we're doing here is we're finding our x value, which is just that border, that value. For example, we wanted all the backpacks that weighed. We were looking last time when we were doing this, it would have said what percentage of the backpacks weighed less than 2.8 kilograms. So we knew the 2.8. Yeah. So this time we knew the 10%. All right, you do all of that math and it would say 10%. This time we knew the 10% or the probability is 0.1. We knew the probability, we were working backwards to find out what weight would that be. Okay? So instead of having the x value, this time we have the area and we're working backwards. Okay?
Why are we using this if we already know the percentage distribution and the mean? Why do we need it?
Because you need to know the x value, and you're going to see why next. Okay? So, because you're still looking for a value. So this x value is the specific boundary point that we were looking for that particular one. Now, and the reason we do that is so that we can then use the information we gather to find the mean or the standard deviation or, God forbid, both. Which we will look at one, but not today. Okay? So, look at page 44. Okay. So those are just a matter of keystrokes. And it's slightly different because that time we weren't looking for the probability, we were looking for our x value, right? So if it gives us x, that's the normal one. If it gives us the probability, that's the inverse one, right? You've got to make sure you keep them straight. Okay? Well, for this one, what we're going to look at is we're going to look at using z to find the mean. Okay? Remember, we had a formula for z-score, and you probably haven't memorized it much because we haven't been using it, because we've been using the calculator instead of the z-scores. You do not have to memorize it. It will be on your formula sheet. But does anybody remember what it is? X minus the mean divided by the standard deviation. There you are. So it doesn't change. Right? So what we've had in the past was we knew all three of these pieces of information. We plugged them in and did the math, and that gave us our z-score, right? But this time, we're not. We're going to have a missing piece of information. And that missing piece of information in this case is the mean. It could just as easily be the standard deviation. Okay? So we're going to have to use a little algebra to be able to work these out, right? Because if you know some of the values, then you can find the other values by plugging in the ones you know and then solving for the one you don't know, right? So you're just using some basic algebra skills. So look at that example there on page 44. It says the weights of students' backpacks are found to be normally distributed with a standard deviation. Okay, so let's list the information as we go, of 0.6 kilograms. Okay, if the probability that a backpack weighs more than 4 kilograms, so the probability is greater than 4 kgs, right? If that probability is 0.0179, okay, calculate the mean of the backpacks. So the mean is what we don't know. You agree? All right. So what we need to do first is we need to find the z value. Okay? First, we'll draw our picture, find out where our information is. Don't ever do normal distribution without a picture. So here's our mean, right? And 4 kilograms, that's a very tiny, tiny, tiny percentage, isn't it? 0.019. So it's a very, 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 very tiny piece of information. Yeah? Now, so what we're going to do is we need to, and we know the mean is here, right? So if this is 4, we need to find the x value for that. Now they're using the chart. You can't to be able to get the value reading from the chart. So let's look at how to read it from the chart. All we need to do, though, is we're not going to be reading those values on the sides. We're going to be reading the value out of the middle. So everybody remember the chart? It's in the back. It's been in the back of your book right there, right? In order to do that, I need a z-score. It's much easier to get that z-score straight from the chart than it is doing any kind of manipulations with your calculator. Okay? So, but remember from the chart reads from the mean. So does my chart read this bit? Nope. My chart reads this bit up to that point. Okay? So the chart only reads in one direction above or below the mean. But we know some information about this. From the mean over is how much of the value? 50%, which is as a decimal is 0.5. Okay? So my chart is going to give me this diagonally shaded region, right? Okay? But I need to find this number. And so to do that, what I'm going to do is simply first find that piece of, well, don't put z, I'm sorry, put probability. Probability is 0.5 minus that little tiny bit. So 0.10179, I'm sorry, okay? Which gives us 0.4821. Okay? So remember that when you're reading from the chart, it's only going to read that information from that one side. Okay? Now, go to your chart and see if you can find 0.4821. See it? It's in the very first column. Just go all the way down. 4821. Did you find it yet? Okay. And right next to it, and they're very nice to you on this one, because right above it is 0, so we don't care. Right next to it is the value what? 2.1. Do you see it, where I'm getting that number? So we went down to 4821, which is right there on your chart. Everybody seeing it on the chart? 4821? It's right there. Yeah? Okay. Sorry? And then so what we're going to do is, well, you just find that value on the chart and then look at the number right next to it. And the number right next to it is in the gray, in the column for the z-score. You see at the top it says z right here? So down the side here, the number right next to 4821 is 2.1. And the number above it is 0. So do I care? Right? So look at, let's just do another one real quick. Everybody find 0.4505 in the chart. You're looking in the body of the chart. Find 0.4505. And they're in numerical order, so it's not too hard to find. Yeah? You finding it? It's right there in the middle. Almost in the center, isn't it?
Uh-huh.
Did you find it? Okay. Then you're going to see it's got z at the top, then it's got some numbers down the side, then it's got some numbers across, right? For that particular one, 4505, I'm sorry, is the z-score on this side. Remember, this one's the first one number you read, and this one's the second part. So the first one is, what is that? 1.6? Okay. But this one, we also have to read up, and it's got what number? So 1.65. Okay? Don't worry about the differences. They're not going to give you anything that doesn't come out to fit right on the chart. Now, they could give you weird ones that had differences that they added to, but they're not going to do that for you. They're not. All right? So, let's do one more. Just make sure everybody's on the same page. Find for me the z-score for 0.4913. Everybody got it?
Yeah.
What is it? Okay? So, you'll find the number in the body and then read off to the side first and then the top for the second number. Okay? All right. What now? No, because remember, you have to include the number at the top too. That's the third digit. The number at the top is the third digit. Because remember, it's the intersection. Just like you were reading an x and a y graph, you have to have an x value across and a y value up and down. So it's going to have an up and down as well as across. Okay, so just like you're reading just like a graph, it's at the intersection of that point. Okay, so we did our number and we have our z-score. Now I have a z-score, I have a standard deviation, okay? Right? And I have an x. That value on the chart, that limit, right? That lower limit is my x value. That's what we've been using as a limit, right? So I have enough information to plug into this formula to find the mean. Okay? So you're going to have to remember, polish off your algebra skills a little bit here to be able to do this. All right? So what z-score did we get for that one? 2.10? Our x was our boundary, which was 4.0 kilograms, which all we're interested in is the 4.0, right? But I wanted, okay. Our standard deviation was 0.6 kilograms. Is that correct? And so all we're missing from that formula is our mean. So that's our unknown. So plug in everything we know. So 2.1 is equal to 4, and you can put 4.0 if you want to, minus the mean, because I don't know what number that is, divided by 0.6. Take a minute, make sure everybody's on the same page as far as where I put what number and why. All I'm doing is replacing z equals x minus the mean over the standard deviation. So the numbers that I knew, I plugged in. Okay? Now let's solve it. Remember the first thing, if you have fractions, the first thing you have to do is get rid of them, right? So the opposite of divide by 0.6 is what? Yeah, but whatever you do to one side, you're going to do to the other. Right? So 0.6 times 2.1, what does that give me, someone? 1.26, thank you. Now over here, they're just simply going to divide away, which is the whole reason we did it. So that's going to leave me equals 4.0 minus mu. All right? Now my point is, the whole point behind this is to get this thing completely by itself, right? It's not by itself right now. I've got to move, so I've got two choices. I could move that negative mu the other way, and that would make it positive. Or I could just move the number to the other side and then change the sign in a minute to get the sign I want. Which would you normally have done, you think? So you think you'd go ahead and subtract the 4.0? Okay. Perfect. Fine with me. Okay. Oop. Now, so what is 1.26 minus 4.0 going to make? Negative. I'm sorry, what? 2.74. Thank you. Over here, they subtract away, and it makes negative mu. But I don't want negative mu, do I? But if I don't want negative, I want positive, that just means change the sign. But if I change the signs on one side, what? You betcha. So just, they both become positive. So.
Do you show that by doing it like times -1?
Now what now?
When you like show that you're changing the signs, do you do it by like multiply by -1 or something?
You don't have to. Actually, what you'd be doing for changing the signs is really dividing by -1 if you wanted to show it. Because normally, say you had 3 mu, to get rid of the 3, you would divide, right? Well, this is negative mu. To get rid of the negative, you would divide by -1. But that's the same as just changing the signs. I don't think that they would be that picky about when you solve this. If you just change the signs, it's pretty clear that I changed the signs on both sides, I think, by just making them both a plus. Okay? I'm not sure. I can check for you though.
One of my internals last year, I don't know about the external. One of the things I showed this.
You had to show changing the sign, how you changed the signs?
One of my internal, I don't know if it's like that.
Okay. All right. Well then, I don't know. Guys, remember, New Zealand curriculum is new to me. So if you think it's better to be safe than sorry, then show the divide by -1. It's not going to kill you. Right? So if it's happened to you in the past, once bitten. Okay? And so there is our mean. Right? Just basic algebra, just solving a basic algebraic equation. Right? So you're going to just find out. So what if I didn't know the standard deviation? What would I have to know? The mean. And then from there, I could work it out. Okay? All right. And, of course, this is the mean. It's got units, too. Don't forget those. All right. And then they ask you, does my answer make sense? Does it make sense that could be the mean? Yes, because 2.74 is less than 4, isn't it? Okay. What if I'd gotten a number bigger than 4? That wouldn't make any sense. And what that would tell you is that you used the other probability value. Okay? And that's what gave you a much larger number. Okay? This is the most complicated thing you're going to be doing, mathematically. Pretty happy with that? Let's look at another one. Just look at number 1 there. We'll just do that one together. The distances jumped in a school long jump competition are normally distributed. Okay? If anytime it says normally distributed, the first thing I'm always going to do is draw the curve. Okay? With a standard deviation of 8 centimeters, do not forget your units. Every time you write these down, put the units. But when you're doing the math, do not put the units. Okay? All right. If the probability that a student jumped less than 160 centimeters is 0.0062, calculate the mean. So the probability is 0.0062 for the x value of 160 centimeters, right? Now that's below. So that's a really, really, really tiny piece below. So where do you think I'm going to do? What tail do you think that is? Yeah, that's down here, isn't it? Okay. All right. So that means my mean is going to be greater than 160 centimeters. Okay. All right. Now, but that's this tail. Does my chart read tails with gaps in the middle? No, my chart will read where? Between the mean and the value. That's your only hang up here. Your chart will read between the mean and the value. So before I can find this value, I've got to find the probability for that second area that I shaded with just the lines across. How do I do that? Yeah. And again, that's only if you have data that's on the tails, because your chart can't read tails. Your chart reads from the mean. Your chart, the probabilities that you get from the chart touch the mean. Okay? Now, so what does that give me for my probability then? 49, what now, I'm sorry? 3.8. Go to your chart. Going into the body of the chart there, do you find 0.4938? Yep, they're being very nice to you again. That gives you a z value of 2.50, which is the same as just 2.5, right? But I always like to include the 0 just because I know I have to look up. Okay, so that's twice they've done it where it's come from that first column. That doesn't have to be the case, though, right? But they will give you numbers that are here that you don't have to do the differences for. Okay? Now, do I have enough information to do the math now? Sure. 2.5 is my z-score. What is my x value? Minus, what's my mean? Don't know. Over, what's my standard deviation? 8. Again, we'll clear the fractions by multiplying both sides by the 8. What's 8 times 2.5 going to give me, guys? Somebody? 8?
20.
Pardon?
20.
20? Sorry, I wasn't listening. And over here, the 8s are simply going to divide away. Gives me 160 minus mu. Let's move the 160 by subtracting 160 from both sides, which gives me negative 140 equals mu. Right? Then, equals negative mu. Then divide away the negative. Gives me 140 equals mu. So that tells me that my standard deviation is 140, which means I got an issue. What's my issue? Yeah. Here's where my tail should have been. Did it matter? Why? It's symmetrical. Who cares? You can put it on either side you want to. It's not going to make any difference. Okay? So that means that 160 was a very high number compared. So we were really looking at this area. But this area and this area are identical, aren't they? So you're not going to care. Okay? Unless it says below or something. It's not going to make any difference to your numbers. Check your answer in the back just to make sure we did the math right. You know you have to watch me like a hawk. You found it yet? I'm not looking, so I'm counting on y'all too. It's question 1 on page 44. Okay, then let's find out what we did wrong. So, we're not dealing with this side. We're dealing with left, so that means it's a negative.
Like that. This side is the negative side. So therefore it should be negative 20.
So we're 2.5 below the mean. Okay, and that would have given us negative 180 because we would have added them.
Yeah, because it should have been negative 20 and that.
And there we go. So negative 20.
Mu is 0.
There we go. Genius. Okay, so it was below. Now, so the numbers didn't change as far as the probability, but we were below the mean, so we need to put negative in there. Good eyes. All right, let's do another so that we can make sure that I can redeem myself and probably do a problem, maybe. Good thing I don't have to take this test, huh? All right. What do you want? Number 4 is good because it's got two, because you're going to have two different things. So the number of hairs on the heads of adults is normally distributed. So here you go to the curve. Normally distributed with a standard deviation, you're going to hate this, of 19,500, but it doesn't matter. You've got calculators. If 90% of adults have fewer than 125,000 hairs. So that means way up here, right? And we're talking about all this space. 90% is almost all of it, isn't it? Okay. And that's fewer, so that means below. We happy with below this time? Okay. So our probability is 90%. Have fewer than, so that's our X value, 125,000. Okay? So that's that number there. Now remember, we're looking for our mean. So the probability is 90%. Your chart reads, what's the biggest number on your chart? 5, right? Or 50, or whatever it is. What is it? 0.5. 0.5. 50%. Why?
Because half of it
It only reads one direction or the other because they're symmetrical, so you only need to read one direction. So what then? Pardon? Your chart only needs to read one direction because the other side is exactly the same, isn't it? So this part here is what? 0.5. This part from there to there, because all of that is 90, makes what? 0.4. So here is the value we're going to read from our chart. And we'll just add in the rest. Okay? Because we're looking for the mean. So all we need is from here to here, right? It's half the data. Half the data is on one side, so the rest of it has to be on the other. I don't care about this side because I'm only interested in from my X value to the mean, since I'm looking for the mean, right? So I'm only interested in what's left. So I don't care about this side. I'm just worried about this information. Make sense? Okay? Remember, we're only looking to get to the mean. Right? So, this is half the data on this side. Then we have the rest of the data on that side. Well, if it's 90%, that's 0.9, right? Doesn't it say our probability is 90% that it's going to be below that? Yes? So that means this shading that I have here is 90% of the data. But our chart reads from the mean. So the mean's right there. Well, this whole side is shaded. So what does that make that whole side? Half of it, right? Which is 0.5. So what does that give me left? The 0.4.
So you just don't need to include like almost half of the data.
It'll be included in there, but we're only looking for the mean. So we're only looking for this bit, this stuff right there. So we're only interested in finding the number. Okay? I'm not interested in finding out what number's here. I'm interested in finding out what number's where. So I don't care. Now I needed to know this amount. Why? So that I could take it away from the whole thing. But what I'm interested in is the number that's right here. Right? So if it's Wednesday, are you interested in what happened to your calendar on Monday? Nope. Did it still exist? Yep. Right. We're not worried about it. Okay? So all we're interested in is the mean. All right. Okay, so let's work it out using the information. Go to your chart, find 0.4. This one's going to have a difference.
1.2
Okay. 8-1. Or 8-2. Is it falling between?
Yeah, because it's what, 0.3997 and then it's either plus 2 or 0. It's either 1.5. 999.